Good afternoon. My name is Stan Forrester, and I'll be your physics instructor for the next couple of weeks. And I'm going to talk to you today about problem-solving strategies for physics. Now, physics problems have a reputation for being difficult, and they can be, especially when you're expected to use multiple skills that are unfamiliar. However, I'm going to show you an approach today that's going to let you break these problems into smaller steps and to be able to successfully navigate these problems. And in fact, this is an approach that can work well beyond physics, and I hope you can get some use out of it. Writing down the key idea is the first of 6 steps in the problem-solving strategy. The idea here is to identify what kind of problem you're actually dealing with. Now, as you move through the learning materials, say for instance your text, each text is going to have associated with it maybe 2 or 3 main ideas. If you can get it down to one of those 2 or 3 main ideas, you've really narrowed down the possibilities of all of the different kinds of solutions or approaches that you can take to solving this problem. I call the second step the stock of data. What we're going to do here is we're going to list all of the data, everything that we know, and even the unknowns that we're going to be solving for. This is going to inform your thinking. It's going to tell you where you're starting from, and by listing the unknowns, it's going to tell you what information is the actual goal of trying to solve this problem. So you have a start point and a destination, and that should really help you solve the problem. The third step is called ID the equation. Once we have the big idea, the key idea, and we have the stock of data telling us what information we're starting with and what information we're going to end with, it's time to take a look through the equations associated with that key idea and figure out which one of them is going to serve us best. Now, it's often possible that we may end up with 2 or 3 equations that we'll have to manipulate algebraically, but this is the next step. The fourth step is solving the equation, or multiple equations, depending on what you identified in the previous step. Now, this is important because we're not really interested in how fast a particular baseball is going to accelerate, how far it's going to travel. But what we would like to do is be able to think about all baseballs. And so what we would want is we want a solution that doesn't involve any particular values of the data. And here's where we're going to get that. That's solve the equation. The fifth step in this solution method is to substitute in the data. Now that we have the equation solved algebraically, we can begin putting in the data. And rather than manipulate the data algebraically, the algebraic solution's already been done. All we need to do is substitute in the data and calculate. This eliminates the error that could be associated with algebraically moving around numerical values. The very last step in the solution method is called the check, or the sanity check. It's basically asking if your answers make sense. This is a physical science, therefore the answers have a physical meaning that we can take a look at. Some of the methods we're going to talk about are, say for instance, unit analysis, or even magnitude answers, just to make sure that your answers are in the ballpark. And I hope that this method, all of these ideas together, are going to serve you well in this course.